Right, so this is the third video of the differentiation series. In this one, we're going to be looking at the chain rule. When we're differentiating, there's actually three different rules that we should be aware of: the chain rule, the product rule, and the quotient rule. So this is the chain rule video, and the next two will be the product rule and the quotient rule videos. So first of all, when do we use the chain rule? We use the chain rule when we have to differentiate a composite function. A composite function is just a function inside another function. So this might be a bit hard to understand, but if I was to give you an example, let's say we have y is equal to 4x plus 5 raised to the power of 10. This is an example of a composite function because if I say, well, let me say let u is equal to 4x plus 5. That way I can write y in terms of u. I can say it's u to the power of 10. So u itself is a function, and that's inside y. So y is a function as well. So it's a function inside a function. It's a composite function. So if this is the case, then we use the chain rule to differentiate it. And so I've shown here what the chain rule is, okay? This is the form of how do you apply the chain rule, but I have a different way of, maybe an easier way of applying it, which we'll go through later on. So if I was to use this here, they say that dy by dx is equal to dy by du times by du by dx, like this. So all we need to do is find that dy by du and that du by dx. So we have u in terms of x, so if I differentiate that, du by dx, I just get 4. We have y in terms of u, so if I differentiate that one, dy by du, we get 10u to the 9. That's fairly simple, right? And so all I need to do is just plug it in now. So it's 10u to the 9 multiplied by 4, which gives us 40u to the power of 9. And because we want to give it all in terms of x, I want to replace this u back in terms of x. So this is now 40 brackets 4x plus 5 to the power of 9. Right, so that's how we differentiate composite functions. But it might be a bit difficult to understand what a composite function is or know when it is a composite function. And so the way I think about it is whenever I see something raised to a certain power, any power, it could be positive, it could be negative, it could be non-integer integers, then I automatically think I should use the chain rule to differentiate. And so I think of 3 simple steps to do it. I say we go power, we go derivative, and then we go power minus 1. Right, this might seem a bit confusing to you guys for now, but if I was to explain it, let's say I want to differentiate y is equal to 7x plus 1 to the power of negative 2. So the moment I see a power, even though it's a negative, I automatically think I need to use the chain rule to differentiate it. And so I'm going to follow 3 simple steps. We're going to multiply each term, so the power term, the derivative term, and the power minus 1 term. So the power term first, the power in this case is minus 2, right? So I'm going to say, bring the minus 2 to the front. I'm going to times that with the derivative, so the derivative of this bracket here. So if I differentiate that, it's just 7. And then finally, it's power minus 1. What I mean by that is I rewrite this bracket, 7x plus 1, and I minus 1 to the power. In this case, it was minus 2, so it's minus 3. Minus 2 minus 1 is minus 3, right? And this is the derivative of the initial y function. So it's just 3 very basic steps. I can simplify this even further, right? I can say it's minus 14, 7x plus 1 to the power of minus 3. Okay. Let's try another example. So let's say I have y is equal to 10x squared plus 2x to the power of 5, like this, okay? So once again, automatically, because it's raised to a certain power, I know actually you'd be using the chain rule. So dy by dx is a 3-step process. So the power comes down. In our case, the power is 5, so the 5 comes down. We differentiate this bracket part here. So if I was to differentiate that, we get 20x plus 2, close bracket. And then we rewrite the whole function, 10x plus 2x, and we minus 1 to the power. So this now becomes 5 minus 1, which is 4. And that's the derivative of this equation. This even works for exponentials and trig terms as well, because we're going to learn the trig terms later on. But if I was to use it in terms of exponential, let's say we have y is equal to e to the 2x plus ln 3x, and that's all raised to the power of minus 1. Okay. Automatically, because power, we use a chain rule. So dy by dx First step, the power comes down, minus 1. Second step, I differentiate the inside bracket. So we've learned in the previous video, right? So if you are still unsure, just go back to the previous video. So e to the 2x becomes 2e to the 2x plus 1 over x, close bracket. And then I rewrite the whole bracket again, e to the 2x plus ln 3x, and I minus 1 to this power, which now becomes minus 2 like this. So as I said, it's very simple. It's just a 3-step process. If you follow these 3 steps, then you can differentiate any function which has been raised to the power. In the next video, we're going to be looking at the product rule, and then we're going to be also looking at the quotient rule.